In this video, I'm going to show you how to do diagrams for two flat plates moving into the future, drawing their features as they go forward in time. This first diagram over here shows you the current set of conditions at 2 million years ago, and we're going to be drawing diagrams for 1 million years later and another million years later that brings us to the present. We're looking at two plates here, plate X, which we are going to hold fixed, and plate Y, which is moving with respect to it at 20 millimeters per year. And I hope you can see this is a ridge here, a spreading center here, there's a transform here, and there's a trench here where X is the overriding plate. Okay, and so just to be clear on the relative motions, we're seeing spreading going on here at the ridge, we're seeing convergence at the trench, and transform motion along this transform. And I just want to make sure that it's clear that you can see, even before sort of doing any of the diagrams, that the motion here is left lateral, where we've got an arrow spreading here, an arrow converging here that helps us to see that this arrow should be moving up, or this arrow should be moving down. All right, the next part we're going to do is calculate how much plate Y is going to move with respect to X between these two time frames, which is 1 million years difference. And so we can use our rate here, where 20 millimeters per year is also equal to 20 kilometers per million years. And so since we're talking about 1 million years, we would be talking about 20 kilometers. You can use this scale down here, where the 20 kilometers would be this distance here. So we're going to be moving plate Y that distance, but again, remember that plate X is fixed. All right, one more thing I should add is that I do want you to highlight the active plate boundary in red, and so that's shown here. Okay, so first thing I would do is I would just draw on the X, because that's not going to move, and then the two dots that are on X, because again, they don't move. Next, I would go ahead and draw in the trench diagram here, just because that is part of plate X. This is X is overriding here, so it's not going to move. Then I would start to look at features on plate Y, and I would start with the dots. So the first thing I would do is I would move this dot 20 kilometers. Again, this scale bar here represents the 20 kilometers from over here, and so I would place a new dot here. Next, I would move this dot here, but again, remember that X is overriding, so even though a dot would normally go here, it will be below plate X because Y is subducting underneath X here, so I wouldn't draw it, I would just remove it. All right, we can next move this dot over here for plate Y, 20 kilometers, and I like to just go ahead and move the letters as well. It's not required, but it helps me to see how things are moving. All right, the next thing I would do is I would draw in the 2 million year magnetic anomaly that resides on plate X. So material that was created at 2 million years ago at this ridge is creating material on plate X and on plate Y. So I'm just going ahead and labeling the part that's on plate X here as 2 million years. That's not going to move. But we do have material that was on plate Y created here that will move 20 kilometers over that 1 million year. And so I'll place another 2 million year magnetic anomaly. This is part of plate Y. All right, so this is plate X, this is plate Y. We must have then a ridge that's midway between them, because that ridge is creating material on both sides of equal amounts. So again, you can measure this. It's 10 kilometers from the original location, because it's half the rate. So instead of 20 kilometers, it'd be 10 kilometers. Or you can really just eyeball that it's halfway in between these two magnetic anomalies once you've drawn them. All right, once you've done that, you can connect the trench here to the ridge here. And then this part here, this is the fracture zone. Okay, so this is plate Y, this is plate Y, this is plate Y. So this fracture zone here just represents an offset in age, but it's all sort of plate Y. This is not an active plate boundary here. All right, the active plate boundary is now shown in red. Again, the trench, the transform, and the ridge. And you can see that plate X has grown in size, that this material here has been added to plate X. All right, last thing would be to write the relative motions. Again, this would be spreading, this would be converging, and this would be transform. Again, same relative motion as before. All right, let's move to the present case. Again, 1 million year difference here, so we're going to move it an additional 20 kilometers. That means it'll be a total of 40 kilometers from the original locations. But again, remember, plate X is being held fixed, so I went ahead and labeled plate X here in the same exact spot, and then we'll just fill in these two dots here because, again, they have not moved. I would also put in the trench here. Again, it's not moving, and this is the overrunning plate. All right, next I'll move this dot here. I need to move it 40 kilometers now, so I'll put the dot here. Again, we would move this dot 40 kilometers, but again, it'll be below plate X. So you could draw it here if you want for a moment, but you should cross it out or erase it again after you're done. All right, this dot here, again, we'll move 40 kilometers out to this location here. And I would go ahead and move the Y down there as well. This is the 2 million year magnetic anomaly, just like we drew before. Again, that, because it's got added to plate X 2 million years ago, it has not moved because plate X is fixed. But you can then measure out 40 kilometers and put the other 2 million year magnetic anomaly on plate Y out at this 40 kilometer distance here. You can see this line, this dot, and this Y, they're all in the same configuration as before because plate Y is sort of fixed relative to itself. So the things that are all on plate Y are not moving with respect to one another. But again, it has all moved with respect to plate X. All right, so midway in between these two magnetic anomalies should be the ridge. So I've drawn that in here. And then you can go ahead and add 1 million year magnetic anomalies midway in between the ridge and the 2 million year magnetic anomaly. Again, you could measure this. This would be 10 kilometers here and 10 kilometers here, but also you can just eyeball halfway in between. Again, this is material that was created at this time, the 1 million year material on plate X here and on plate Y here. All right, so now you can go ahead and connect the trench here with the ridge here using a transform. And again, this is fracture zone on this side. All of this is plate Y now. This is the ridge here, and this is new material added to plate Y. This is the old plate Y. So we have just a fracture zone here that's not active plate boundary. The red here highlights what the active plate boundary is. Again, we've got to add our relative motions. This is spreading here, converging here, and transform here. Okay, I'm hoping that's clear how I would like you to go about doing this, both for ridges, transforms, and trenches.